How's it going? Welcome to this episode of the Sold Out Podcast. Today we're here with Akhil Voorakkara, head of electronics at Eirloop, genius behind the Seshcam, all this stuff.
Yeah, so do you want to tell us, kind of start us out about maybe Eirloop, what you're doing in that, and so on?
No, absolutely, guys. So Eirloop, which I'm glad you guys have heard about it. It's a pretty exciting thing. So I don't know, you guys I'm sure know about the hyperloop.
Yeah.
So back in 2014, 2013, I think it was, Elon Musk came out with he wrote a paper essentially theorizing transport that would be faster than a plane, but just as convenient and as cheap as just taking the train or whatever it is. And he called it the hyperloop, and it's one of those concepts from a sci-fi movie or something like that. It's really cool. It's long vacuum tubes, going across countries and everything. Connect.
It can't have any air in it, isn't it?
No. I'll get to that.
Yeah.
So you look at so they're vacuum tubes for the sole reason that when you have a vacuum, there's no drag or any environmental resistance or friction or anything like that. And that's actually a much bigger problem than you would think. You look at buses. Buses are essentially massive blocks, they're big bricks. The amount of fuel they actually waste
Because
they're not aerodynamic is a lot higher than you would think.
Yeah.
And it's not just fuel either. Buses can't go very fast because when you have a square shape like that and you're going very fast, you get a lot of turbulence. And when you get a lot of turbulence, you start shaking, and that's not safe or fun for the passengers, And so when you're in a vacuum, you get none of that, no air currents, no nothing.
Yeah.
And you're essentially not pushing against anything. There's no resistance. And then the other thing with the hyperloop is it's supposed to be maglev. So when you have maglev, then you have no mechanical resistance. So literally the only thing that you're working against in the hyperloop is gravity, which is just going downwards. Going forwards, there's essentially nothing, except the forwards component of gravity, but that's negligible compared to mechanical drag and the aerodynamic drag. Yeah. And when you have that, you can use you'd have a solution that would use the same amount of power as your average train.
Yeah.
But it would go the speed of sound.
And
that's what's really exciting about it. And at Eirloop, that's the future that we're working towards. That's the future we're making happen. So, Elon Musk released the concept, and he was like, "All right, go do whatever you want, make it happen." Yeah. He was like, "I don't have the time to do it myself because."
How many countries are involved?
So this year, about I think 9 or 10 countries are involved. So about half the teams, over half the teams are actually about half the teams are from
the US,
from the US, North America, and then the rest are spread around the world. I'll get to that later. Just to keep going with the background. So he was like, "All right, make it happen," and it wasn't happening fast enough. So then he was like, "All right, I'm going to get a little bit involved in it," and he created, using his two companies, SpaceX and Tesla, he created a competition. But and a competition for students only. Now I think he said students only just to get cheap labor out of us, because you tell the students, you have the opportunity to do something really cool, we'll jump at it.
We'll might as well
go all in it. We have nothing better to be doing, sure. And so this competition is in its 4th year now, and the competition essentially invites student teams from any institution, any country, to submit proposals for the fastest hyperloop pod possible. Because the first challenge is getting the speed, getting there. Let's get to Mach 1.
So each competition was a different aspect. So one might have been about speed.
So last year it was actually about suspension, because right now it's the maglev aspect hasn't really come into it yet. There's a levitation sub-competition, but that's what the losers do. The people who can't go fast do that. So, but now it's really about, let's just get to the speed in a vacuum, And so he created this competition. As I said, last year it was about suspension. There was actually a pusher, which Tesla built themselves, which would push your rig essentially down the tube at, whatever, I think it was 300 kilometers an hour, and that itself is very fast. It's pretty incredible. But, so this year it was all pods have to be self-propelled. So this year it's propulsion. This year it's how fast can you go, and it's not like you have 10 kilometers. It's not like you have a big straight road.
Yeah.
You have 1.2 kilometers. That's it. You know, it's not even a mile.
So acceleration is a big part of it as well.
Yeah, acceleration and braking. So you have 1.2 kilometers to get as close to the speed of sound as possible, and then stop as well, because you know you go through the end of that tube and you've destroyed $16 million worth of equipment.
Yeah, exactly.
And that tube is on the SpaceX headquarters.
Yeah.
You know, it's on SpaceX property, so you don't want to be going through the end of that tube. So this year, you know, there were over 700 teams entered the competition.
Yeah.
So you're talking about like your MITs, your Cambridges, your Oxfords. None of those three got in this year, coincidentally.
Yeah.
In fact, there's no team from England this year,
Oh.
but there is a team from Ireland.
That's it.
You know, this
So
year.
it's the first year that Ireland's been in.
Yeah,
as
it's
well.
the first year Ireland had actually put an entry through, and we've got in on our first year, and that's huge.
Yeah.
Like our closest competitor, the Edinburgh team. You know, they're Scottish, not English.
Yeah.
They have been trying to get into the competition for 3 years now, and they only got it this year.
Yeah.
And
you got it the first year.
And we got it our first try. Yeah. And so just to tell you about the process of getting in, so around the start of semester 1, September, that's when they have a deadline for an intent to compete form. This is just where, you know, you kind of get the team together, you put down your universities, you have a letter from your university saying, these students are going to do this thing, let them do it.
Yeah.
And then, sorry, 1 second.
Yeah, no, you're good.
And then you submit that letter, and then you have like 2 months to put together a preliminary design package, and this is like sketches, rough works, you know, approximate part numbers, and essentially just a big presentation, but it essentially makes up the idea, the rough idea of what your pod would be. You know, how fast you think your design could go. And then only 40 out of over 700 people who applied for the preliminary stage, well, teams, institutions essentially, only 40 get through to the next stage, which is the final design package. And this is a more detailed document.
Yeah.
This is the one where you actually have to have, you know, CAD models. You know, you need to draw it up in SolidWorks. You need to pick out your parts. You need to cost the thing. You need to be like, it won't blow up.
Yeah.
You know, that kind of stuff. And from there, only 20 teams get selected. And those 20 teams have been invited to build your pod, ship it all the way to California, send it down that tube as fast as possible. And this
see
year
who comes out on top.
Yeah, and that's it. See who comes out on top. And this year Ireland has a representation, and we have a pod that's going to go over 500 kilometers an hour. And just to put that into perspective, that's like, you know, 5 times the motorway speed limit.
Yeah.
It's 200 kilometers an hour faster than the fastest Formula 1 cars.
Yeah.
This is like this.
Insane.
Our pod itself could go from Dublin to Galway in 25 minutes.
No way.
You know?
That's crazy.
In 25 minutes. Like, of course, the real hyperloop
Yeah,
in like 11 minutes.
Yeah.
But our pod itself could go that fast. And funny thing is, if we had more distance, we could have actually loaded up a few more batteries in our pod. And we probably could have pushed somewhere closer to 900 to 1,000 kilometers an hour.
But is it, the one question I wanted to ask over the whole thing, is it viable?
Is it viable?
Will it happen?
So what's the...
So this is the question, is it viable? Everyone asks that, you know, people asked that when the first cars came out. You know, when the first cars came out, people laughed. People were like, only the rich will ever use it, you know. In fact, you know, when I do this presentation, when I do the Eirloop presentation to potential, you know, backers and supporters, because it's a student project, and students, as you know, I'm sure, have no money. You know, and so the whole thing has been sponsored by the universities. We have corporate backers, and you know, our GoFundMe as well. You know, I'm sure you guys might be able to throw that link out. That would that would help.
In the description, we'll put it in the description.
We need all the help we can get, essentially, and so. Thankfully in the competition as well, we don't have to care about viability. There's one criteria and one criteria only: fastest pod wins.
Oh yeah.
So we had to do the cool stuff. But so like when I say, we have a pod that's going to go 500 kilometers an hour, even that, people laugh at it. People openly will laugh while I'm doing the presentation. But then I put that into perspective. I'm like, and then, you know, we're not the only ones saying that our pod will go 500 kilometers an hour. There are rocket scientists in SpaceX. These are the people who have vetted our application. These people read through our presentation. You know, they looked at what we were doing. And if they say we can do it, the people who make rockets, the people who send rockets at 5-6 times the speed of sound into space, say that it can be done. I think absolutely it is technically feasible. And economically feasible, absolutely. In fact, it's already been paid for in India and in Dubai. In India, there's a huge route that Richard Branson's Hyperloop 1 is going to be building from connecting Bombay to essentially the centre of India. And that deal has been made. You know, the contract has been signed by the Indian government and Hyperloop 1. Interesting fact, Hyperloop 1 won this competition that we were in the first year. And now they're building the real thing. And they're also doing the public transport for the UAE, so like connecting Dubai, Abu Dhabi, and those places.
That's what I heard, that they got the first license for the Hyperloop, didn't they, Dubai? The first license, so when it's going to be ready to be built after all the information they gather. I think one of the things from the competition, isn't it, just to gather all this data that students got.
Yeah, it's essentially us doing the grunt work, you know, like making it happen, you know, seeing like what technological changes need to be made to conventional designs. For example, our pod. So you know you have your trains. So our pod, as I said, it's not maglev, because first let's get to the speed. Take things one step at a time. So you know you have your trains, cars, everything. The wheels are vertical. You know, our pod, the wheels are actually horizontal.
It's a monorail, isn't it?
Yeah. So there's a I-beam, essentially a monorail that goes through the entire track, 1.2 kilometers. It's of course made in sections, which means we have to have suspension because of the bumps. And that's a whole technical challenge. But so because we drive with horizontal wheels, the horizontal wheels aren't holding up the weight, and because they're not holding up the weight and they're not under as much compressive force.
Oh, I get you.
They can actually spin at higher RPMs, which is why our pod will go on paper, of course. But the thing is, everyone's designs are on paper. None of the teams know even remotely how their pod is going to perform until we get over there. That's kind of the excitement. So on paper, our pod will go over 500 kilometers an hour. You know.
But it could go faster, it could go slower.
Yeah, of course. Over 500 kilometers an hour, and that's like 150 kilometers an hour faster than the fastest pods to date, you know, the War pod, which won last year. And their pod had a conventional, you know, horizontal, you know, and I think Swizzloop unveiled their pod a week or two ago, and their pod is essentially a go-kart that just locks to the rail, you know. But this is the thing. This is, I think, why Eirloop made it through to the finals, and we made it through to the finals without any follow-up calls about our brief or anything, and we're the only team to have ever done that. You know, in fact, in the actual official competition website, it states you have to have a Skype interview with the SpaceX team about your design. We didn't have that. They just sent us straight through, you know, and that just goes to show the innovation behind the design.
You brought something new to the table in a sense, and they just saw it. And
so our pod is kind of like maglev in that nothing actually touches the ground. You know, which is pretty cool. I'm sure you guys will be able to throw up some images of the pod, and people can see exactly what I'm talking about.
Has the Eirloop been revealed? Has it?
No, so of course we have to build it. Right now it's under construction. You know, we actually just ordered like 22,000 worth of mechanical parts the other day, and of course we have to pay for that now.
And you have to build it as well.
Yeah, what all these sponsorships and all the money being donated, is that all just being used to get all these parts and stuff, isn't it? And it's real expensive stuff.
Yeah. Everything is like going towards the pod. You know, let's build the pod, and then of course shipping the pod and getting ourselves.
And what's the estimated final cost of the pod, do you think?
Our pod, not that much. Like, considering when we did our final design package, we were like, we need 330k to do this. Our pod is going to cost like, I think 200k of that. But now we're looking at a pod that we're going to be building for under 40k.
Whoa.
You know?
So you cut that down? Like,
we cut that down, and we made our pod faster at the same time. Because originally we had a motor that was going to... So our pod is actually dual motor as well. That's never been seen before. So because there's two horizontal drive wheels, they're both driven independently by two motors. So originally we had these two massive motors that were like, altogether the motors with their controllers were like 65,000. Just that alone. You know, this is not counting the frame or anything. Now our motors and motor controllers cost like 3,500. That's it.
So that's way down.
You know? But of course they're a lot less powerful than the 65k. But the thing is, because they're a lot less powerful, they need a lot less power. Because they need a lot less power, the pod is a lot lighter. And because the pod is a lot lighter, it can still go as fast as our original design, but at a far lower cost. And I guess that's the interesting thing about the competition. That's what the competition is trying to promote.
Yeah.
You know,
Innovation.
reducing the cost of a Hyperloop pod. Like for 30,000, we've made a pod that could carry cargo. You know, not humans because it's not pressurized. You know, like a plane, but that could carry cargo across Ireland in 25 minutes. You know, we've built that already. That's how advanced. Getting back to feasibility. That's how advanced the technology is. You know, we're there. It's happening. It's coming. And it's about getting people to embrace that.
And that's with limited budgets and students as well.
Yeah,
you know?
That's with limited budgets and spending money we don't have.
Yeah.
You know,
pretty much.
Well, I think before you went into this competition is just for the pod. So you have all the measurements, all this stuff for the actual tubes.
Yeah.
I feel that's what helped. I feel a lot. Because if you had to design the pod and the tubes,
knowing that all the other teams are on the same platforms as everyone's doing the same thing, everyone has the same challenge. That helped a lot. Having the set requirements, but that's exactly it. That's the great thing about this competition. It gives people a solid, focused challenge. It's not like you have like NASA's X Prize, and they were like go to the moon for like under a certain cost. Go to the moon and we'll give you $1 million. There weren't really any requirements, and in the end, no one won that competition.
I feel too much creativity is involved and stuff.
People just went,
Crazy.
But with this, like we were given fixed guidelines. We had really tight. We're still under a really tight deadline because we are shipping the pod in exactly 4 weeks. You know,
and
we haven't even started. We don't even have all the mechanical part. We don't even have any of the chassis yet, and we have to ship this pod in 4 weeks, which is pretty exciting.
Yeah.
But I think just last Friday we got our motors, which is really cool.
So that's like one of the main.
Yeah. So like, just to make it clear, like this is actually happening. We have our entire powertrain. We have all our pods electronics. Right now, the big challenge is just getting all the chassis together, and of course.
Then shipping over
Shipping,
as well.
yeah. But we have a sponsor coming on board helping out shipping. So.
And what's the date for the actual test? Is it all done on the same day? Is it
this is cool. The competition is from the 14th to the 22nd of July. That's about a week. And the reason it's a week isn't because there's like 20 teams. The reason it's a week is because SpaceX spent 6 days testing your pod. SpaceX spent 6 days bashing your pod, kicking it, essentially doing everything, all but blow it up, to make sure that once you send it down that pod, it does not destroy their $16 million investment,
fair.
And then essentially, that's actually kind of a race, because the first team to jump through all those tests is the first team in the rail, in the tube on Sunday. And on Sunday, all the teams that have passed all the tests get to go in the tube. I think last year out of the 24 teams that were there, only 3 made it into the tube.
Oh no way!
So safety is a huge aspect of our pod, and that's why we on May the 31st just there we had to send off a safety brief outlining all the checks we were going to do, why our pod is not going to blow up, and why our pod is going to be unreal. And our safety brief was kick-ass. So hopefully they'll be very happy with that. And our plan is to turn up at SpaceX with a lot of the tests already done. Of course, there are some tests we can't do
like you can't put it in the blocking.
Yeah.
And after you pass all this testing that SpaceX do, you only have two goes to make it go as fast as you can, don't you? It's only one.
Yeah, just one.
Just one.
You just get to it's in the tube, press go, and that's it. That's your shot.
Oh.
So
that's all you get, just that one go.
Yeah, you just get one shot. That's it. Like if you fail on the first shot, they're like, no, it's not. It's clearly.
Oh, yeah. Even if a second and third time, it might average out at something else.
Yeah. So it's like you have one shot.
Yeah.
But that's the thing as well. Like when you have our pod is built very much with one shot in mind. Like the batteries will be at 0 by the end. Like we could have put more batteries on, of course, and then just taken longer to accelerate. But the reason there's less batteries is, of course, weight saving, less weight, go faster, and so on and so forth. I
think everything is probably so planned through.
Yeah.
In a sense.
Yeah. No. You should see the spreadsheets. Oh my god. Yeah, we have a really great team behind us.
Yeah, the team looks really good. It looks solid.
Yeah. So it's when I say the Irish representation, I mean it. It's not like the team from MIT. It's not like the team from Waterloo University or the team from Edinburgh, where they're from University of Edinburgh, University of Waterloo, MIT. We're the Irish representation because we have 8 different universities on board for this. 8 different universities have come together, and we're not just talking about like all the big universities like DCU, UCB, Trinity. We're talking about like even we have members from like IADT, NCAD. It really is the Irish team.
It's a broad team.
Yeah. And we have team members from all ranges, like first years like me leading departments. I'm head of electronics for the team, and then we have PhDs who are doing finite element analysis, stress analysis for our pod and things like. It's interesting. We have like 1 PhD on the team. The team that won last year has like 40 PhDs on their team who are doing this as their PhD. And like, but that's the thing, to be on the same level as them, to be able to compete with them is huge.
It shows the potential your whole team has in terms of
absolutely
the knowledge, like what everybody can bring to the table.
Yeah.
And that's why it's good that it's so broad. I'd say everybody has something else to bring.
No, that's it. Like, and of course everyone is welcome. Like as I said, we need all the help we can get, and that's why. When we were forming the team, when we were doing our bits, essentially we were just like anyone who was interested in joining, come to the meetings. Yeah. That's all you have to do is show commitment. But and the cool thing is when you have a team made up of mostly like first and second years, everyone knows nothing. You tell these people, all right, what do you guys want to do? And they say, oh, I want to work on the brakes. Make the brakes happen. It's up to them to do the research. It's up to them to stay up till 5 a.m. Googling shit. It's them that.
And so, as the head of electronics, what have you learned or what have you done so far?
So, like for me, it was very, very interesting. So, I've actually the reason I became head of electronics and being the first years because I actually since like secondary school every summer I had been working in the industry. I've worked for robotics companies.
The pharmaceutical companies,
R&D companies, medical device companies, and I've worked for consulting companies, and I even worked at a 3D printer manufacturer.
This is in secondary school.
Yeah, this was all through secondary school, like last summer.
During your leaving cert, everything.
Before, just like even during 6th year, I even worked like the Christmas holidays and stuff. So because of that, I had the expertise in designing. So the systems that control the pod, they're under a class called embedded systems. They're embedded. So I'd worked a lot in embedded systems. And I was one of the early people to join the team. So I'll tell you after this how the team came about. That's a really cool story actually. So and from the start I was like, electronics is yours. I'm doing electronics and computer engineering. It's my favorite thing. I have a real passion for it. So I drew up the schematics and everything. So but I learned a lot in that. Working with new devices, working with new sensors, and like a lot about safety. Before a lot of the things I had done, I didn't need to think too much about safety. There wasn't like a huge responsibility. There wasn't like I'm going to owe Elon
like
Musk
a restriction.
I'm going to owe Elon Musk 16 million if I fuck up. It wasn't like that before, and I learned a lot about. So, like for example, to tell you a little bit about our electronics, the brains of our pod essentially. Arguably the most important. We have one computer. It's just a Raspberry Pi, which may not sound pretty, pretty impressive or whatever. Like I see 7-year-olds use Raspberry Pis. But the thing is, we're using a Raspberry Pi to send something 500 kilometers an hour, and it's pretty nifty that it actually has the power to do that. So that's it. But the thing is, the Raspberry Pi actually handles none of the sensors. Everything is subsystems. We have 10 different subsystems. We have like brake temperature subsystems. Battery pressure subsystems, because the batteries are actually in their sealed vessel, because if you put batteries in a vacuum there's nowhere for the heat to go and they will explode. They will blow up. So we have a big ass carbon fiber box with the 12 batteries in. The batteries are crazy. They're like 100 volts, and that's quite a lot. 100 volts DC. It's not like 230 volts AC, which you haven't. So 100 volts DC. But as you know, voltage isn't the thing that kills you. You get magicians passing 2,000 volts through their hands and stuff, and lightning bolts. It's the current. But when you're talking about current, like 20 milliamps, like a milliamp is 1,000 of an amp. 20 milliamps will kill you. Each of our motors draws 400 amps at peak current.
Shit.
400 amps, and that's what we're working with. So the cables are like this thick. It's,
so it's like you're saying, it's all these safety things you have to think about.
Yeah. So and then I have all these subsystems, and learning how to integrate all these subsystems, and making everything modular. Say one subsystem fails, I should be able to just plug it out, plug another replacement one in, and that was really, really awesome. Designing a completely redundant system that where anything could just be
kind of pop
take
in
it
and
out, pop in and out,
Replace
and making
change,
it, and then making it really fast as well. With programming, a lot of things programmers do is use a lot of libraries. Libraries are just essentially big pre-made code, which you can just modify, chop and change to do what you want. But the thing is, when you include a library in your compilation, you include everything in that library, even the stuff you're not using. So it takes up a lot of space and sometimes wastes clock cycles on the CPU. So I had to do a lot of stuff where I would actually look in the libraries and I would actually write my own much shorter library, just the functions I need. So that was a big thing, learning about efficiency, because when you're drilling at 500 kilometers an hour, every millisecond matters.
Especially when you have that short time, as you were saying, like you need to get there, stop as well.
Our entire run is going to be 16 seconds long.
What is it, 1.2 kilometers?
Yeah, we're going to do 1.2 kilometers in just 16 seconds. That's
you have to demonstrate that you can go 500 kilometers an hour in that.
Yeah. So we have 900 meters to accelerate, and then we have about 350 meters to brake. And the thing is, like,
a bit of
that's like, for that 300 meters to work, our brakes have to engage. Like our backup system are just springs, but they only provide it. So our braking system is pneumatic. You could do hydraulic, but then you have the liquid, and that's unnecessary weight, which is why you just use air. So it's pneumatic. Like those things, in the blink of an eye, they actuate with, like 1,500 newtons of force, which is huge. It's huge when the pod only weighs 120 kilos. And so if those springs were all we had in the end, then our pod would literally be kissing the end of the tunnel.
It's crazy to compare it to something even like a plane or like a train. How much time they have to brake, And like a plane has a whole runway.
And
to
runways
land
are kilometers long.
And you have this 350 meters to stop something going 500 kilometers an hour. That's crazy.
Well, that's the insane technological challenges we have. And going back to safety, like our brakes, for example, what we had to do was design them to be power to release, which means that say all power was cut off, then our brakes would actually engage when all power is cut off. So you actually have to send power to the brakes to release. So you get interesting challenges like that. And then another interesting challenge, because our pod is wheels, actually. It's actually the same thing. But the challenge is that you don't a lot of people say entrepreneurship as they have the stereotypical you have to come up with the next big Facebook, the next big thing, or for yourself, going into design, or you have to create something. It has to be as big as Supreme straight away. It has to be an overnight hit. But it's never an overnight success. It's all about doing bits.
Exactly. Exactly.
And the bits really add up. Like as I said, I've been doing this kind of stuff for years. I've been doing hackathons. I've been working in industry for years, and I've just been doing it, but under the radar, building my own profile, and then now every year it gets bigger and bigger, and that's it.
And it's probably all this experience is exponential, literally, like you said. Every year it's something bigger you're doing. Like you're designing a pod that could be used potentially in Ireland in the future, or all over the world even.
No, exactly.
And it also goes to show, obviously, we're all the same age, we're all have the same resources, and the different things that you can do if you just apply yourself.
It is.
And do what you're interested in.
It's literally a lot of people are. I guess there's a bit of a culture in Ireland where people are like, oh, fucking why is he successful? And people are kind of afraid about their image, but you have to kind of just let that go and do it for yourself more than anything, Do it for I know that sounds maybe a little bit selfish, but it is about I'm interested in this. I think I can do something really good in this field. Just do it. What's stopping you? I think the biggest thing a lot of people say is oh, I don't know anything. How could I do it? I didn't know anything when I started.
Yeah.
I'm sure you guys didn't.
Yeah, exactly.
We're only two.
Yeah.
You know, you guys didn't know anything when you guys started. You know.
It's an ongoing learning process.
But it's just about like, kind of, it's all about being arsed. You know.
Yeah.
You just have to be arsed to like go learn about this shit and do it yourself.
Yeah.
Like for example, at the start of college, there was like a hackathon for like an electronics hackathon. You know, it was like. Create an artistic experience using a certain technology that will enhance students' everyday lives.
Yeah.
It was hosted by like DCU and Intel. And like, you know, people would see hackathons and think, oh, it's all going to be like fourth years, master students and all that. Me, I literally dragged my college friends, like a load of first years. And it was me, a team of all first years, and like 2 slightly higher up students. And like, I went up, I pitched my idea. Yeah. You know, I pitched the idea to the entire room of what, there were like 140 people involved in that hackathon. I pitched that, and over the weekend, so a hackathon lasts a weekend. Over the course of that weekend, me and essentially 9 other first years, we designed a product. We built a prototype of that product. We made a presentation about it. We did the whole business research. We did all aspects of it.
Safety guides, everything.
Yeah, everything. I presented it. And we won the hackathon. Yeah. You know, we beat like fourth years, we beat master's students, we beat them all. Just because we had the ambition, we had the drive,
exactly,
you know. And all my first, like, I'm like one of maybe 3 people in my year who going into college was already into the entrepreneurship, already doing stuff. Yeah. But I got these guys, and all the 9 people had never done anything, but I was like, look guys, I've been doing it. Because I've been doing hackathons since like 4th year, and I was like, it's easy.
Yeah,
come on, just do it. And they're like, oh, I don't know anything. And I'm like, but this is how you know things,
exactly.
you know.
Yeah.
And then in the end, like me and the boys, we went and we won like 5 hackathons. Yeah. Like in the end, we we made such great connections. Yeah. We got a free trip to Paris out of it and stuff. Yeah. And it was just because I was like, look, there's nothing to, and it's like. You know, what have you got to lose? Like, you know, maybe you lose the weekend, but like, it pays off in the long run.
You simply just have to
that
apply yourself, like you said. It's all about just deciding that you're going to do it, and that's it. Yeah. Not having any like drawbacks and like just setting the thing, second thoughts and stuff. You know.
No, that's it. Like,
just say you're going to do it, but really interesting stuff.
Yeah, thanks for having me. Like,
no worries. If you want to shout out all of your social medias and any upcoming projects or anything.
No, absolutely. One shout out I want is just at Eirloop on Instagram, at Team Eirloop on Twitter, at Team Eirloop on Facebook as well, and just I guess follow our journey and see where we're going, and hopefully you guys will see you won't see flames.
And even on the Facebook it's interesting because you have little things about all the members and all this who's doing what. It's really interesting. Everybody should go check it out. And this will be on YouTube and SoundCloud. So
perfect.
That's it.
Cool.
Anyway,
great stuff.
Yeah, I'll just like fade it out somewhere there. So
that's good.
Perfect, man. Honestly, thanks so much for coming through.
Thanks for having me.